There's a variety of notation and different ways of asking questions involving antiderivatives, and this video is going to address some of those notations and different question phrasing. Okay, so for example, one from the definition of an antiderivative, we know that capital F of x is an antiderivative of a function little f of x that's been given to you if the following thing happens, that when you take the derivative of this antiderivative function, you get the original function in question. Okay, so this is one particular notation of an antiderivative, that if you want to find the antiderivative of some function, say little f of x, then you would use capital that letter for its antiderivative. So for example, if we had g of x, is equal to e to the 5x, we could say the antiderivative of e to the 5x is 1/5 e to the 5x, because when you take the derivative of this big G of x, or antiderivative function, that by properties of our derivatives, the 1/5 as a constant comes out in front of the derivative. The derivative of e to the 5x as an exponential function is e to the 5x multiplied by 5 because of the chain rule, and then the 1/5 and the 5 cancel out and you're left with e to the 5x, which is equal to the function little g. So the big little letter function notation is one way of doing antiderivatives. Another notation we might see is that alternate notation, and we're going to see this a lot more coming up in the next several days. Alternate notation, and perhaps a bit shorter, is that if you want to find the antiderivative of e to the 5x, this weird elongated s symbol combined with the dx notation is the antiderivative of the function e to the 5x. So if you want to find an antiderivative of something, you could say antiderivative. This notation is the antiderivative notation, and if you want to say of a particular function g, that you would put the g of x notation there, and this together says that the antiderivative, that's the notation in pink, and then when you say of the function g of x, that's what happens when you put a function in this notation. So we could say here that the antiderivative of the function e to the 5x is 1/5 e to the 5x, and that is a slightly more concise notation. Okay. There's also a notation, right? Just to make you think about things. What if I said that f prime of x was equal to 2x? Okay, so let's say that I've given you the derivative, and that derivative is equal to 2x. Okay, could you tell me what function had 2x as its derivative? Okay, could you fill in the blank here? And essentially what you're being asked to do is to fill in the blank. What could you take the derivative of to get 2x? What function could you have taken the derivative of to get f prime of x, which was given to you as 2x? Okay, and if you're thinking that the answer is x squared, you would be correct. So here is also a notation that is kind of an antiderivative question in disguise. You might be given a derivative, and your question is to find the function that has that derivative. That is also an antiderivative question. x squared is the antiderivative of 2x because the derivative of x squared is equal to 2x. Okay, so I'd like to explore these three different notations. Right, here are the three different notations we might see, and let's look at some different phrasings of questions to see what might happen. Okay, so here is a typically phrased problem, section 4.8, antiderivatives. Here you are given a derivative. Okay, you're given that y prime of x or f prime of x, depending on how you want to write it. Given f prime of x, you're given a derivative, 3x squared minus 2x plus 1. Okay, and in this problem, they want you to, there's some fancy language for solving each differential equation, which is just a fancy way of saying you're given a derivative. And they want you to figure out what function, could you fill in the blank, has this as its derivative. Okay, so I think we can see hopefully that x cubed, okay, minus x squared plus x is the function that if we took its derivative, we would get 3x squared from here. Derivative of x squared is 2x, so there's our minus 2x. The derivative of x is equal to 1. Okay? So we've basically been given the derivative, and we are being asked to find the function that has that as its derivative. So we have found a function f of x, and that function is 3x squared minus 2x plus 1. So we're partly done with this problem. Okay. Let's write some alternate notation here. So alternate notation, we could say that we were given the function f prime of x, 3x squared minus 2x plus 1. We could say that f of x is equal to x cubed minus x squared plus x is the antiderivative of f prime of x. Okay, that is one notation. Because we have figured out what function we could take the derivative of to get f prime of x, and that is this function here. So that's one of the notations. We could also say that the antiderivative of the derivative function is the function f of x. Okay? This was the alternate notation we had. Okay, so one thing that we're talking about in this section with differential equations is essentially that you've been given a derivative, and you want to find what function has that as its derivative. So this is just an antiderivative question. Okay, so we're partly done. Okay, but there's something additional given in this problem, that we also need to find the function, the antiderivative, okay, that when x is equal to 2, y is equal to 1. Okay, so if you'll observe here that this function that we thought was our correct answer, that if you look at this function f of x is x cubed minus x squared plus x, and if you evaluate that at 2, you'll get 2 cubed minus 2 squared plus 2, 8 minus 4 plus 2, that is equal to 10 minus 4 is 6. And this problem wanted us to find an antiderivative that when x was 2, we got a y value of 1. So what we're finding here is that for our antiderivative function, the function at 2 is equal to 6, but that is not equal to 1. Okay, so we need to figure out what's going on here. And what is important about antiderivatives okay, is that antiderivatives are not unique. Okay? Unlike derivatives, if I ask you for the derivative of sine of x, you're going to tell me that the answer is cosine of x. That was the only answer for the derivative of sine. But if we reverse this problem, and I ask for an antiderivative of cosine, you could put sine of x here. Sine of x is an antiderivative of cosine of x. But sine of x was not the only antiderivative of cosine of x. You could have also put sine of x plus 5. You could have put sine of x plus 10, or sine of x minus 2. Okay? All of these, all are antiderivatives of cosine of x. And the only thing that makes them different is the constant that is on the problem. Because all of those are antiderivatives, because the derivative of sine of x plus any constant, the derivative of sine is cosine, and then the derivative of any constant is equal to 0. Okay? So antiderivatives are not unique. There's more than one antiderivative of a given function, in this case cosine. There are lots. Any constant added to an antiderivative will also be an antiderivative. Okay, and that will let us go back to this problem that we had a second ago and finish it. Okay, let's see. Let me clear this page. So now we'll go ahead and finish this problem exactly as they wanted. Here we have a derivative given. They want you to find an antiderivative. Find an antiderivative of f prime of x is equal to 3x squared minus 2x plus 1. Okay, so that when x is equal to 2 in that antiderivative, you get a y value of 1. Okay? So we know in this problem that f of x, being x cubed minus x squared plus x, is an antiderivative. But we also need to say that any constant added to that is also an antiderivative. Okay? So this problem here is what's called the most general antiderivative of f prime of x. And now if we want this function, when you plug in 2, you will get 8 minus 4 plus 2 plus a constant, which is equal to 6 plus c. We want that to equal our y value of 1, which means that c has to be equal to -5. Okay. So one thing we can say is that the antiderivative of this given derivative, so that x is equal to 2 and y is equal to 1, that antiderivative, or sometimes called the solution of this differential equation, is x cubed minus x squared plus x minus 5. That is the answer to this problem. So ends this video.